Okay, so we had our celebrities up here on this diagram, and that was based on their popularity. The more popular they were, the higher up they were, and attractiveness. The more attractive they were, the more to the left they were, okay? Well, we're going to use this diagram, and instead of having TV stars and movie stars, we're going to have real stars, like the stars up in the sky. So we're going to change a couple of things. First of all, this type of diagram will be called the HR diagram. And that stands for Hertzsprung-Russell, a couple of guys who came up with this. Instead of talking about hotness, we're going to talk about temperature. So the temperature starts way over here with the cooler ones and comes over this way. The hotter you are, the more to the left you are. And that's a little bit different because normally we would start with a 0 over here and work over this way and just get hotter and hotter and hotter and keep on going over to the right. But a Hertzsprung-Russell diagram, an HR diagram is different. The cooler ones are over here, and as you get hotter, you come over to the left. Instead of talking about how popular a person is, we're going to talk about that says brightness, the brightness of a star, how bright that star is, and that's also called magnitude, all right? The magnitude or brightness of a star, if it's very dim, some stars are not very bright. If it's very dim, it will be along the bottom, and as it gets brighter and brighter and brighter, it goes farther and farther up. So let's start off with our sun. It's a star. The name of our star is called the sun. All right, we always start off with that, and our sun is very average. It's average size, average temperature, average color, and all that, and it goes right about in the middle. So if something is brighter than our sun, it's going to be higher. If something is cooler than our sun, it will be more over here toward the right. If something is hotter than our sun, it will be more over here toward the left, okay? So let's go with another star called Alpha Centauri, Alpha Centauri B. Alpha Centauri B is almost the same temperature as our sun, but it's a little bit more dim. So I'm going to put it a little bit lower because if it's dim, then it goes down this way, okay? It's about the same temperature. It's a little bit cooler, so we come over this way to the right just a little bit. Now we have Barnard star. Barnard star is quite a bit more dim than our star. It's way down here, not very bright at all. You could easily look at it and it will not hurt your eyes at all if you were up close to it, but it's pretty cool also, all right? So it's going to be over here some. Then we have Wolf 359, a star called Wolf 359. It's even more dim than Barnard star, so it will be lower, because if it's dimmer, it's lower, and it's cool, just a little bit cooler than Barnard star, so it goes right about there. Now we have some stars that are brighter than ours. Vega, this star is called Vega, and it really is a blue star. It is quite a bit warmer than our star, so it's going to go this way, because if it's more warm, it goes this way, so we go this way, and it's also 60 times brighter than our star, so we move up some. Okay, it's warmer and brighter than our sun. Our sun is right there. You know what, I'm going to put a little arrow. That doesn't work. I'm going to put a little arrow. That's our sun right there. Here's another star. I don't know how to pronounce it. Achernar, maybe? It is much hotter. It's like 3 times hotter than our sun. So it comes over this way. And then it is 200 times brighter. So it's hotter, so we go toward the left, and it's brighter, so we go higher. So I'm going to put it right about there. And then we have a couple of stars, Rigel and Beta Crucis. Rigel and Beta Crucis. Let me start off with Beta Crucis. Beta Crucis is a little bit hotter than our sun, but it is a whole, I'm sorry, I apologize. It's a lot bright, forget what I just said. It's a lot brighter and a lot hotter. So because it's a lot brighter, it's going to be going way up high, and because it's much hotter, it will be going way over where the super hot ones are. It's going to be up here. And then we also have Rigel. Rigel is even brighter than Beta Crucis. It's not as hot. So because it's brighter, It's going to go up higher, but because it's not as hot, it doesn't go over as far. So it's going to go right here. So it's not as hot, because if you're hotter, you're going closer to that line, but it is brighter. Then we have Aldebaran and Pollux and Arcturus. And Aldebaran and Pollux and Arcturus are all about the same temperature and brightness. They are brighter than our sun, so they're higher than our sun. They are also, but they're not as hot, okay? They're a little bit cooler, right? So they're brighter, but they're a little bit cooler. So they come down here toward the not so hot side. And they are all right about there. And then we have Antares, and a lot of students like Betelgeuse. Antares and Betelgeuse are not that hot. They are much cooler than our sun, so they are going to come over this way, but they are brighter, okay? They're not as hot, but they are brighter. So they go up here, and they are very, very similar. That goes right about there. And we have a couple more. Procyon B and Sirius B. These are much smaller stars, except they are very, very hot, right? Sirius B is way over here. It's extremely hot, but it's not bright at all. It's very dim. So it's hot, we go over this way, but it's not very bright, so it comes down. So it's going to be right about there. And Procyon B is right about there. It's pretty dim also. Now, something I want to make sure you know is, just because these two stars are next to each other on the diagram does not mean that they are next to each other in space. Pretend that there are two people in class named, their last name is Williams, okay? If two people in class are named Williams, on the roster, on the teacher's class roster, they will be right next to each other on the teacher's class roster because they're organized by their last name. But in the classroom, they probably aren't sitting right next to each other. One could be way over on the left side, and one could be way over on the right side, so they're not next to each other in real life in the classroom, but on the teacher's roster, they're next to each other. So right here, please don't think that this star, Alpha Centauri B, is right next to our star, the sun. They could be way in different directions, but they are very similar, so on this diagram, the HR diagram, they're next to each other. So what do we see right here? These right here are called the main sequence stars. These are main sequence. These are the red giants right here, and these are the red supergiants. These are called supergiants because they are super big. These are just called the red giants. Oops. These are called main sequence. And if those are the red giants there, you can probably guess these are called the blue giants. And these tiny little bitty things right here are called the white dwarves, and I spell it this way, but some people spell it, I don't care how you spell it as long as you know what it is, all right? Boys and girls, stars start off right here in the main sequence, and our sun is a main sequence star. Eventually, as they get older, they will either become a giant or a supergiant. And then as they start to get very old, they end up becoming a white dwarf, and they could possibly, depending on their size, they could possibly become a black hole, all right? So it's main sequence, then it goes up to the giants, and then it becomes a dwarf or a black hole, right? Please go over this, memorize these categories right here, main sequence, giants, supergiants, dwarves, and that order. And if you have any questions, please make sure you talk to your teacher. Also, don't forget, the cooler ones are down here, medium ones are here, super hot ones are here. The more dim it is, the lower it is, the brighter it is, the higher it is, all right? Thank you.